So this is a training attempt number 2. This is being composed after we had our meeting with Lenny up in South Greensburg, and he gave us his information regarding the parts in the assembly. So I'm ready to give you the first part to modify, or to make rather, and I'm going to explain the background of what I did. So he gave us this, I got a screen clip of that bill of material, or actually it's a packing list that he get. So this is what I'm doing, just so you're kind of understand the whole process. It's not that important, but for what you're going to do, but you'll see what's going on. So this is a McMaster-Carr shipping list, and this is their part number. And if you go to McMaster-Carr, and we're going to do that, I'll give you. You're going to find that in prototyping and stuff, it's the most convenient place to buy things, but they're expensive. But you pay for the convenience, because normally if you order it today, it'll be here tomorrow. They ship out of like nearby Ohio. So if you're a commercial customer, sometimes you can order the parts like at 3 o'clock and you'll get them at 9 o'clock when your UPS delivers. Anyways, so you take over here in McMaster-Carr and you can type in the part number, which was 95630A630 for the first part. And it brings up this. So this is their search mechanism for washers, and you can, if you're looking for a part and to see if they have it, they have very good search mechanisms. But we already know the part number, and so we can click on. It gives us a description here, but for our purposes, we always reword a description. I have this fetish, as you'll find. The part naming should be noun that tells you, answers the noun, or a couple of words that answer the question, what is it? All right. So this is a washer. So PTFE, that's the abbreviation for Teflon. So it's not Teflon. It's a Teflon washer, but the first thing is it's a washer. This is kind of like how the military names things. So it's going to be, I'm going to rename it to be a washer, and then give it sizes, and then its material as the last portion. But you don't have to worry about that. What's nice here is if you click on this, here they give you a drawing. They give you a dimension drawing already. And over here, well, here they give you more specs about what you're ordering. And they tell you, here's how we sell it. It's $10 for a pack of 50. So they're not cheap. You can put this on your order. But here you can also download CAD models already made, which is nice. For instance, there's a step file. There's IGES. There is I think SAT stands for, it's like a STL file. But anyways, we're not going to use that. We're going to model the file from scratch. And here's the dimensions that we're going to use. And so the pertinent dimensions are the OD, the outside diameter, it's 9 millimeters. Inside diameter, 4.3. And this is just reference information, this M4 screw. So metric screws, I don't know if you're familiar with, they use the M prefix to say it's a metric. And then the 4 is the nominal size in millimeters. So an M4 is 4 millimeters in nominal size. So you can see that if the hole is 4.3 millimeters, that screw should pass through the hole without any problem. And here we have the thickness given as a range of materials, because there's some tolerance on this raw material that they make the washer out of probably. So we'll have to decide how thick to model that. Probably what we'd just use is the average thickness, so we'd use 0.8 millimeters. Anyways, that's what we can get out of here. So when you're making your part, you can use that as reference information. I'm going to stick it on my side screen so you're not going to see it. And the next thing we're going to need is we're going to need to know. Oh, so what happens is I'm taking this information and I have created this database from prior lives that is good. I use it for tracking parts. So there's a lot of information when you're in production that you want to keep track of your parts in an organized fashion. And so I use a database to do that. And when we were talking about the other guy named Bob Snyder, so I worked at this, I was a contractor at the same place Bob was, and him and I were working through how to really make a good system for tracking all the electrical components for this company. Well, all the components, but he was working on from the board, making a print circuit board standpoint, and we were working together a little bit on it. Well, they let me go before the thing got done, but I have all the code, so I've rolled it into something I've been working on for my own personal use. So anyways, what I did is I put that part into my system. And if you recall in the meeting, I was asking Lenny about how do you want to number these parts and blah, blah, blah. So I just made the executive decision. All the part numbers are going to begin with a G and a V. And that stands for ground voltage, because that's what that thing does. They're measuring the voltage in the ground. So I'm figuring that's pretty generic, but it's kind of clues maybe Lenny and Bob in if they see these parts flying around their place. They know, oh, that's associated with that project. So that's what we're going to do. So the first one is going to be GV001, and it's going to be this washer. So like I said, I renamed the washer to be a washer flat M4 screw 4.3 ID by 9 blah blah blah. So I took the same information and just reorganized it, because to me the most important attribute is it's a washer. That answers what it is and what type of washer. It's a flat, and then this gets into the size and the material. So there we have it. And then what I also do with this, I grab a thumbnail of it. So in my system here, when like for instance, this is not going to have a thumbnail down here. Yeah, no image found. But if I look at this, I say, well, I can't remember what that flat washer looks like, believe it or not, so I can click on the thumb and it brings it up. And then what I did also is I took the information, I cut and pasted. I have a little program that takes the information I enter in the database, and then it makes this automatically generated Word file that is going to be the documentation that we can give the customer to document this part. And since this is a commercial part, we're buying it, we don't have to specify it's how made. There's probably a lot of other companies will sell us this plastic washer. This is set up so that we can have alternate vendors on this list, so that any vendor can be one that whoever's making these can select to use to supply this part. But what I did is I just copied the information from the McMaster-Carr page instead of recreating it. So this gives enough information for the client to either go out and quote making this part, or have someone else find an equivalent for it, or if there's a vendor making the whole thing, they can use this for their guidance on what this part's supposed to be. And then of course we'll make a PDF that actually what we give to the client. We'll hold on to the Word document. They won't need that. Okay, so that's all great, but we still don't have a solid model. And like I said, we're not going to use a solid model that we can download, because what's the point? We want to learn how to make solid models, right? So now it's time to go into FreeCAD. And so what we know is that we have a description that we've settled on, and we have the part number that we're going to assign. And then we're going to use that information as we build the part. Okay, so let's go into FreeCAD. So here, FreeCAD's just sitting waiting. I haven't done anything. So I'm going to do File, New Document. And then, see, now this is where I'm not really sure how we're going to do this, but we're going to start off, we're only going to have one part per file. So this is going to be, so the first thing we're going to do File, Save As, and we're going to call this, I like to save only by part number, GV0001. Okay, and we say Save. So this file is going to only have, this is the file name, and the next thing we do, if we follow the mango jelly thing, is we're going to add a a body. Okay. Can we do that? Click. There it goes. Now, the thing about a body is, body has these attributes. I want to take, and I'm going to delete that body, and I'm going to use this part icon instead now. And what it says, a part is a general purpose container to group objects so they act as a unit in 3D. So let's just put that here. Let's see. Yeah, so the advantage of using it a part is that, see the part under here, it has these attributes down here. Type, material, ID, license, URL, blah, blah, blah. So the ID, we could put in the GV, what should we do? GV001 here. Material. Let's see what they have here. This is going to link to what they... No. I'm really not certain how to use this stuff in our context yet. I'd like to have the description in here, but there doesn't really seem to be... Oh, label. Username of the object. So that's this label up here, I'm pretty certain. Yeah. I think what we're going to do for now, until we come up with a better thing, is we're going to go with the part, and then we're going to put a colon. Oops. And then I'm going to grab part of the description here. Where can I do that? Go back to my database. Don't get too bogged down in this. You can tell I'm kind of like trying to figure out what to do here. Let's take, I don't know, this is going to be long. Probably not, it's going to be long and ugly. Well, maybe not too bad. Yeah. Maybe that'll work. Okay, so if we use the body doesn't have a place to put this information, so we don't know what to do with it. And the colon may be important later in life if we have to separate the part number from the description. Anyways, okay, blah, blah, blah. Okay, so now we're going to add a body to this part. Okay, so now this is where I have to back up. Well, maybe not. One thing, you have to note that notice that the things are in bold because this is the active object. And this, before you add the body, you got to make sure whatever you're going to add it to is active. For instance, if this is not active, and I'm here, and I do add see the body now is outside of the part. This yellow thing is a grouping, so it groups things under here. Now this body would not necessarily be grouped with that part. It's separate because when I added it, the original body, the original part was not active. All right, so much confusion. Now, if we want to add a sketch, so the body is just another type of holding device or grouping device. I gotta turn the light on. Okay, so the basic this I guess maybe what I was saying in my first videos is kind of more correct than I thought. Okay, so switch the part design, add a new part, make it active. Okay, maybe we're going to add some steps in here about insert. I'll come back to this. I need to insert some steps here so that you save the file as the part number, rename the part to be the part number plus a description, and that was about it. Okay, I'm gonna pause and I'll be back. Okay, not sure where I left it, but the next step is to make sure that the body is active. So the body has to be bold and highlighted, and this active body, when I right click, should be checked. So there we go, it's now bold. Now, I'm going to pause another time. Okay, we have our body active, so now we want to create a sketch. Most parts, I'm going to say 90% of parts are going to be started off, the first feature is going to be driven from a sketch, and it'll either probably be a extrude or a revolve. An extrude or a revolve. So in this case, I'm going to make a revolve. And if you're going to ask why am I making the washer as a revolve, you're going to have to go watch the first video, because the first video I go through the two ways of making it. And my reasoning for making it as a revolve is that you can access all the variables by opening one sketch. So let's just go ahead and do it. So I'm going to click the sketch icon, create a sketch, which is like a white piece of paper with a red circle and a red rectangle on it. It says new sketch, so we click that. Now it wants me to select a sketch plane. So sketches are two-dimensional things, so they have to be put on a flat plane. And it doesn't really matter, but since the front is the XZ plane, that's what I'm going to pick. Oh yeah, in the other video I talked about these. You really probably should watch the other video, because we're going to build the parts the way I talked, by using the part node plus the body node, because of the ability to name it and give it the part number in the ID field. So I think the first video is still valid, so you might want to watch that. I know it's going to be depressing watching all my stupid videos, but anyways. Okay, so here we are. This is the origin. That's the 0, 0 for this plane. The x-axis is red, y-axis is in green. And when you go into sketch mode, you get all these fancy tools across here. So the first set, starting with the dot, all the way up to this B-spline. These are like things we draw. Polylines, which are connected lines and curves. Straight lines, types of arcs drawn in different manners. Notice that when there's a little down arrow, you have an extended menu. Different ways to draw circles and ellipses. Different ways to draw rectangles. This is really powerful, because like a lot of times you'll need to have your rectangle centered. There's a couple ways to do it, but using this item where you draw a center point and then a corner is real powerful. And this gives you like your higher order polygon type things. Triangles. So a lot of times if you're drawing a nut, you'll need a hexagon. This is nice because it draws it for you. One thing we have to learn about is that in this, FreeCAD is what they call a parametric modeler, which means it's geometry of the 2D sketches driven by dimensions that can be mathematical relationships. Like I think I mentioned to you a long time ago that you can actually drive your parts from a spreadsheet in here and have calculations that change dimensions and even logic in there. And so that's what being parameterized is all about. Anyways, okay, there's different types of slots. These are higher order curves. We're not going to get into using, basically our go-tos are going to be polylines, circles, and rectangles, and the hexagon, and maybe a slot now and then, but we're going to be dealing with very basic shapes when we sketch. Then we move into what are called constraints. So I can put down some lines. This is just for talking purposes. Okay. And then, so I drew a polyline, which means the lines, each segment is chained together. And then to cancel, I use the right mouse button. So FreeCAD's communicating some things to us already. First of all, white means that the entity is not fully constrained. Like for instance, you can see that there's this little arc with a dot on it. What that means is that this point is constrained to another line. So this point, if I hit escape to clear my cursor and get a pointer back, if I click on this point and start dragging it with holding the left mouse down, I can only drag it along the x-axis because the constraint says mathematically you must be on y equals 0. This is an equation. There's an equation behind the scene saying y has to equal 0 for this point. If I go to this point that's in red, there's no constraint. I'm allowed to do whatever I want with it. And likewise, I think this is constrained red because we have a constraint that says that this line segment is attached to this line segment always. That's right, because this is the constraint over there. That's called a coincident constraint. If I take that let's just look at, so this white node has no other constraints. It's not constrained to another line segment. It's not constrained to the x-axis or anything else. So if I take, and in the sketch view, we have this task panel that gives us sketch related information. And so this is telling us for this 2D sketch we have two constraints. We have this constraint of coincident. You notice if I select it, it turned green. We have a coincident holding the endpoint to the x-axis, and then we have this constraint 2, which turns green, which says keep these two endpoints constrained together. So if I delete this constraint over here, I can select it and hit delete. That node turns to white. It looks like it's connected, right? It looks perfectly beautiful, right? But if I go and move this, you can see I clicked and I selected the segment, the endpoint of one of the segments. And you can see there's no construction here. So let's just go back and kind of put that here, like right on top, right? Looks like, let me zoom in a little bit. Let's put that right on top. All right, looks good, right? But those still are not connected. They're still not connected. I think I can click this and I can still move that away. So if we want those 2 points to be connected, we have to tell FreeCAD, hey, connect these 2 points together. So we do that. We can select the endpoint. We use Control, and then I'm using left mouse to select the second endpoint, and we have those both turn green. This icon here is a coincident constraint. So that brings the 2 points together. You see the red has reappeared, and our constraint over in the left panel has reappeared. That reconnected them. So now we have a joined two segments there. So if we want to say we're trying to draw a right triangle in here, right? So we can, if we want to get this point to be stuck to the y-axis, we can use this. We'll go in the reverse. You don't have to pre-select and then do the constraint. You can say, I want to do coincident. I want this line to be coincident to this point. So it moves it there. I hit escape, and now I can see that if I try to move that point, I'm using left mouse on that point. It will not deviate from that line, from the y-axis. Now remember, we still got this guy floating out in space. So we talked about coincident constraints. We can also use, there's horizontal and vertical. Let's go through them. This joins two lines together, or two endpoints, or makes a point and a line coincident, right, in line. This one forces lines to be horizontal or vertical. This forces things to be parallel, perpendicular, tangent, or collinear. Oh, I didn't know they would do collinear. I always did that a different way. Oh, we learn something every day. Equals, symmetric. I don't even know if this is block constraint. Constrains the selected edges as fixed. I don't know. And this one, I've never used this either. Okay, so I don't know. So, like I said, we're going to make this a right triangle. So one way we could constrain this is we could constrain this point to the origin, which would be a good idea, right? Or we can say, we could first constrain this to be vertical. You can type V for vertical, or you can go up here and use your vertical. See, it gives you the shortcut command there, V. So that does that. And then we could add another line that we can select to make a line segment. We can go from this point. Notice it'll change. It's showing me the coincident constraint there. And then likewise, when I do this, it shows me. So then I click. Now we have that joined together. Escape button. And see how this is now constrained. And let's see, I could either constrain. Let's constrain this now to the x-axis. So select that. Select the x-axis with using Shift. and then constrain. Okay, now we have a right triangle. We can see that the corners all are red because they're all constrained, but we don't have, okay, in this corner, the right angle down here, this corner's pinned because the fact that stuff's on the X and stuff's on the Y, it can't move, but we can still move these guys around. So we could either add an angle between the legs or we can add a length. So you can use the dimensioning tool a couple of ways. You can explicitly say, I want to put a horizontal dimension on here and pick, and then it asks you what dimension you want. So this is part of where the mathematics in being parametrically driven comes in, because right now it's asking for you to give a dimension. So this is almost 3 inches right now. When I hit 2, it's going to move, it's going to try to apply 2 inches while still trying to hold all the other constraints we've already assigned. So no matter what, it won't violate those other constraints. So now if I hit put 2, everything's good because it's able to move. It resizes. Now we still have, and now this line segment turned green. Green means it's fully constrained because the points are pinned down to the x-axis and it has a length. So that means that line segment is it's fully defined. There's no more ambiguity about it. But we still have these white lines that are telling us not everything is constrained down. Now you don't always have to constrain everything in your part, but it's generally a good practice to constrain everything because if you just eyeball it and say, oh, this is going to be an isosceles triangle, right, where these two legs are supposed to be equal and they're not, then you're going to run into problems, right, later in life. So it's good to say, if we want to make this an isosceles triangle, we can do it 2 ways. I don't know if you remember what isosceles has 2 equal legs. So either we could make this height be 2 inches, or we can make the angles both be 45 degrees, because that's a trig thing or a geometry thing. But so let's just make the other leg 2 inches high. So another way to do it, the dimensioning tool is actually kind of smart, so that whenever if you just select it and pick a point, it will try to do dimensioning for you, but you can actually override it and pick other points, and it'll pick the suitable type of dimension for what you're trying to do. So it kind of speeds up. You can just push the D on the keyboard, put you in dimensioning mode, then you can just select stuff. So I selected that line and pulled my mouse to the right. Now I'm going to click, and then we enter 2, and now my triangle is fully constrained. Everything's green. The corners are all closed up, and I have a beautiful triangle. And you can see these are all the constraints on the left that drive it, and we have 3 different line segments that make it up, and it's 2-dimensional. I'm using the Revit keyboard mapping for pan and rotate. So for me, it's Control middle mouse and move the mouse, and I can rotate around. Of course, you can use this. I talk about this in the other first video. You can use this icon to see I think you're probably familiar with this from the bamboo bullshit. Okay, anyways. So we made a simple part using the constraints and so forth. So another thing you can do, so you can understand how parametric stuff works. I gotta remember how to do this. I'm going to delete this dimension. So I'm going to double click this dimension. And there's a place down here where we can give it a name. So I'm going to call this leg 1. Oops. Why is that not? Oh, my caps lock must be on. Okay. So you can name your dimensions. Okay, so now say I want to make a rule that says that, now this is kind of advanced, but this is so you have just a little glimmer of what this parametric stuff's all about. I have to actually go look up how to do this, so I'll be right back. Okay, we got the syntax. So let's say we want to have a rule where this height, we're not going to worry about being an isosceles triangle more, but we want to have a rule that says this leg 2 is always 1/2 the dimension of leg 1. So in this case, if this is 2, we want this height to be 1. All right, so let's put a dimension here. And so we'd want it to be, but if we make this 2, we want this to be 4. So we would have this family of proportional triangles. But if I change this right now to be 4, this doesn't change because there's no reason for it to change. It's a fixed value. It's a constant. But if I change this to be a formula, see this f of x means formula. I can do something like this. Remember I called this leg 1 over here. So I can say I want it to be constraints dot leg 1. So constraints is it's a kind of a command. It says, hey, go get a value from this current sketch called leg 1 and divide by 2. Let's see. Why not? Leg 1 divided by 2. Okay, and it worked the math out there, and it says the result's going to be 2 inches. So we're going to say OK. And we're going to say OK again. So now, instead of having a red dimension, I have this orange one. And it gives you a little clue that, hey, that's a function dimension. So now, if I change leg 1 to be 2, 1/2 of 2 is 1. So you can see now that the triangle automatically adjusts its other leg height. So this is called parametric design. And you can have all kinds of complicated rules that do all kinds of dimensions. Like for instance, not that we're going to do this, but if you're designing a series of screws that all have the same like bolt head but different lengths, you can see that you may want to parameterize the length of the threads or something. Anyways, okay. So now this is just still a 2D item. So when you're done and happy with your sketch and hopefully all the corners are closed up, you say close, and then you can extrude this sketch. So now I talk about this also in the other video, that these yellow icons are additive operations, and the bluish ones with the red are cut operations or subtractive operations, and then these last set are like arrays and that type of stuff. So they keep the more popular commands maybe to the left of the screen. So this is the extrude. So if we click that, now the key thing is if it shows you a preview, it means that you did have a closed up sketch. If you don't get a preview like this, it means your sketch has a problem with it. It could be there's overlapping lines, or it's not closed, or the current constraints don't solve, or what have you. So anyways, over here there's the parameters for the extrude now. So you can decide which way do you want it to extrude. So there's 3 choices. You can extrude just one direction, or you can have extruded both directions from where the sketch was created, and you can have different dimensions in both dimensions, or you can have it be symmetric, which means it'll have an equal spread. And if you're doing one dimension, you can switch to reverse the direction also. So here's the length. You can set your length in here to be what you want. We'll say 0.1 inches. What else? Normally that's about all you have to do. You say OK. And bingo bango, you made your first extruded part. No big deal. You get the front view. And if you want to change it, notice your tree over here. Now you have a pad. So the pad is the additive type process, and it has an eyeball. So the eyeball is like to show or hide. Likewise, I mean the tree is what they call, it has like a parent-child relationship. So like this is the great grandfather, the very first parent, say, making the part, which has the body as a child, which has the pad as a child, which has, if I expand, it has a sketch as the child. So you have a history here, you can go back and modify the sketch later in life if you don't like its dimensions, or let's say we wanted to add a hole. I'm just going to add a floating hole here. So notice it's unconstrained because it's white, and I say close. So now when it extrudes, it'll find that intermediate area and extrudes that without adding a feature. Another way to do that would be, go back, let's delete that thing out of here. Another way to accomplish the same thing would be to say, let's do another operation, another feature, a sketch on this plane. So I select the plane, then I select the sketch icon. Now, what's that done is put me on that face. Remember, 2D sketches need to be on a plane, a flat surface. So that's a flat surface. Now I can select a circle, and it's going to go onto that flat surface. I say close, and now in this case, I'm going to use the pocket operation. And then likewise, you can set a depth and a dimension or directions and all that happy stuff to make a cutout. In that case, now we have two features in our tree. We have the pad, which was the initial additive process, and then we have the pocket, which was the negative process. All right. All this was just to talk about the sketcher a little bit. And I want to show you how your sketch can go bad, okay? Because this is, maybe with these easy parts you won't have problems, but I find it to be very frustrating when you don't know how to troubleshoot your sketch. So what I'm going to do is I'm going to delete this line. And now I'm going to put a segment in here. And I'm going to pretend, I'm going to put it really close. Okay, so now when I look at that, it looks like it's closed. It looks like, well, actually, you can see that this, I wasn't even that careful about how I did this, but you can see these aren't connected down here. I want to connect these. So I can use a window select, hold the left mouse, and drag, so it select both of those points, and I can say make them coincident. So this is now closed up. But this looks closed, but if I go zoom in enough, you'll see it's not. So now, remember this sketch is already an extrusion, so let's close. And it's showing me a little red error here, and if I hover, it says wire is not closed. Now, for some reason, they call your sketch a wire, so they're thinking that the wire is something you loop around and it closes up. So that's just their terminology. I mean, I don't know, it's a little weird, but what it is. So actually, what I'm going to do, I'm going to pretend like we didn't pad this yet. So we could be in the state where we created the sketch. It looks good, right? So now I select the sketch and I try to extrude it. So I get the panel for padding it. You'll notice I see the pad, but I don't see any preview. Okay, and if you have these windows on display, it says wire is not closed. So if I say OK, it says wire is not closed. So now, okay, so this is the frustrating part. So now I say cancel this, but it looks closed, right? It looks like it's all sealed up. So this is a common issue for a lot of people. So there is actually a command. If you go to sketch, no, not there. Select the sketch. How do you do this? Yeah. So I click on the sketch, then I go to the sketch pick at the very top, and I say validate sketch. And then there's another different task panel that comes up. I just keep the defaults, which is highlight troublesome vertices, and click that. And if you pay real close attention, you'll see it did something on that corner. And I'm going to zoom in. I don't know if you're able to see it. I'm going to do the same command. Select the sketch, go to sketch, go to validate sketch, hit highlight troublesome vertices, and it puts a very small highlighting at that intersection. So now we know what the problem is. It's this corner. So what I'm going to do, I'll edit the sketch by double clicking, and now, if I zoom in enough, we can see the problem, right? But you don't have to be that far zoomed in. I can do that window select, right mouse button and drag, and then I'll say make coincident. Now everything turned green, even the corners, so and then I can say close, and I can go back and do my pad now, and you'll see I get the preview, right, and I say okay, and pow, there it is. So that maybe will save you some time, but I'm sure you'll forget all that. Okay. So now we're not going to make this stinking triangle. Let's make our washer finally. So I'm going to just edit the existing sketch. Well, I'm going to just delete all this stuff. So my preferred way of making a flat washer is to sketch the profile. So I'm going to go over here and sketch. And what I'm going to do is, this is going to be the cross section of the washer, which I'm going to revolve around the y-axis, so that will give me the 360-degree donut shape. So now when I drew this rectangle, I made sure to land. I used the 2-point rectangle, and I made sure that the x-axis was highlighted for the first point. Then I clicked the left mouse button and then did a drag to the upper right and clicked again. So that pinned me down. The lower segment is pinned down to the x-axis. You'll notice too that these little lines, the rectangle, we know a rectangle has to have 90-degree corners, and by default it makes the lines of the rectangle horizontal and vertical. So these things are already constrained. Like the only thing I can do is change the shape, the height and width. Everything else is constrained as far as there's no angles. But if I delete this vertical, now you can do something like this, because there's no constraint forcing an angle on this. So I can select that, and I can do V for vertical and put that constraint back on to get it back to be a normal rectangle. So here we go. So now if we review our cut sheet for our, let's find it now. Let's go look at this again. Remember, this is what our washer is like. It's going to have a 9mm outside diameter, a 4.3mm ID, and we use 0.8mm for the thickness. Okay, so 9mm for the outside. Now remember, what's going to happen is this thing's going to get revolved, right? Let's just show you what a revolve looks like. So revolve is the second icon from the left. Click it, and it just so happens it revolved around the y-axis like we want it to, because sometimes it could revolve around a different axis and we would get a different type of shape, and that we don't want that, obviously. So sometimes you have to change the axis or tell it what axis to revolve around, right? So that's a washer, but it doesn't have any dimensions on it. So let's go back in, and you can do this a couple ways. You can go down here and change your units to be millimeters, kilograms, so millimeters. So now if I put in a dimension of 9, if I dimension like this edge from here to there and make it 9 millimeters, I'm wrong, right? Because when I revolve this, that was a dimension on the radius. So this is one of the downsides of doing it this way. So the easy way to fix that is just double click it and say 9mm divided by 2. And then it'll do the math for you, and now you have the correct dimension. Likewise, I can dimension the inner edge to the center line, and it's supposed to be, the inner diameter is 4.3, but we divide by 2, and we get 150. Bingo. And we need a height. And now I'm going to switch back to inches just so you see a different way of doing this. It says this is most of my, I think it's imperial decimal. Say most of my work is done in inches, but one thing just happens to be metric or whatever. So if I dimension this now, it's going to give me an inch dimension. But you can override the units here. I can type in, remember it was 0.8 millimeters. Oh, I think it's lowercase. I get my caps lock off. And it'll do the conversion, make that inches. Yeah, that's about right because 040 is 1 millimeter. So this is kind of, oh, and see, notice all these dimensions converted over to inches too. Let me just do the math there. So like 177 times 25.4 is 4.49, which is, that's the outside radius, times 2 gives you outside radius of 8.9916. So there's a little bit of round off here. Anyways, it's 9 millimeters. So there we go. So now everything's dimensioned, and I could say close. And there is my beautiful washer. The only thing left to do is maybe we want to change it from the default color. And this is a nylon washer, so maybe we want to pick a color that kind of looks plasticky, maybe. Although there might be a way to apply material too. You know, let's try that. Let's see this body. I mean, I'm learning stuff too here. I'm going to pause and see what the deal is. Forget that. It'd be good to do, but I don't feel like researching it right now. But I do know you can do this. You can click on the body, right click, and you could do a couple things. You can say random color, and it'll just randomly change the color, which is convenient. It's fast. But maybe we don't want our plastic washer. I mean, these things are like an off-white, not a blue. So if you want to change it to an actual color, right click, do appearance, click on custom appearance, pick on diffuse color, and then pick a color using the color selector here. So off-whitish, we'll pick this thing. And close, click away. So there you go. Close, save, and there we have it. We have the first part is done. Not very difficult, but it's the basics. So now to start our next part, we could close this. It would be a good idea to close this document and then open a new file, rename it to the new part number, and just proceed like that so we don't get confused. All right, that concludes this video.